In episode 56, titled Protect and Monitor Internet of Things Deployments, we frame IoT as a class of high-risk endpoints that only become safe when identity, segmentation, and observability are treated as first principles rather than afterthoughts. These devices collect data, issue commands, and sit in places where ordinary computers rarely go, which means the blast radius of a single lapse can stretch from privacy exposure to physical safety. The workable posture is to assume every device is untrusted until it proves who it is, where it belongs, and what it should be doing. From there, we narrow what it can reach, verify how it behaves, and preserve enough evidence that any surprise is brief, bounded, and explainable. Protection starts with seeing the estate as it actually exists, not as a spreadsheet hoped it would. Automated discovery should enumerate device type, stated purpose, business owner, firmware and bootloader versions, and the exact switch port or access point where the device lives. Passive fingerprinting helps when devices speak odd or proprietary protocols, while active probes validate what services are exposed and whether defaults linger. Tie discoveries to tickets so owners confirm intent and correct labels when reality disagrees with plan. The outcome is a current register that links a physical object to an identity, a network locus, and a human custodian, because anonymous gear emits anonymous risk. Not every device deserves the same leash. Classify risk by the data handled, the impact of control failure, the degree of external exposure, and the maturity of vendor support. A badge reader near a door with real-time authorization moves differently from a breakroom sensor that reports temperature every hour. A camera streaming to a cloud tenant has different risks than a valve actuator tied to a safety system. Vendor posture counts, signed updates, clear vulnerability advisories, and reasonable end-of-life horizons translate into lower operational surprise. Write these factors plainly so the class explains the policy, then use the class to drive where the device can live, how it authenticates, and how intensely you watch it. Segmentation is the spine of the design because it limits what an adversary can touch when a device misbehaves. Devices land in narrowly scoped networks with no unsolicited inbound paths, and egress is constrained to named services and destinations the device truly needs. Allow lists mention identity and service, not just addresses, and east-west traffic is absent unless a proven dependency exists. Gateways enforce protocol sanity, so tunneling tricks cannot smuggle surprises through permitted ports. And logs at boundaries tell a crisp story of which device spoke to which service and why. When segmentation is right, compromise becomes a contained nuisance rather than a cross-floor incident. Onboarding is where most deployments succeed or fail. Require unique credentials per device, never shared across a fleet, and replace password schemes with mutual certificate-based authentication wherever the platform allows. Disable default services, close unneeded ports, and remove factory accounts that exist only for convenience in a lab. Make enrollment a guided, auditable flow that binds a serial number to a cryptographic identity and a business owner, returning configuration that places the device into the correct segment with the correct policies. The device should leave onboarding with the minimum entitlements necessary to do its job, and no generic keys that turn one lost unit into a fleet-wide liability. Configuration is a line of defense when identity cracks. Favor secure boot so only signed firmware runs. Require signed configuration bundles, and verify update channels before applying changes. Updates should arrive over authenticated, integrity-protected transport with pinned endpoints. And change control should record who approved what, when, and on which class of devices. Store a golden configuration and a last known good version so recovery is swift if an upgrade goes sideways or a device begins to drift. The principle is simple. The device should not accept code you did not mean to run, and you should be able to prove that claim with signatures and logs. Observability turns guesswork into judgment. Establish telemetry baselines for each class, beacon intervals, protocol mix, typical volumes, and expected destinations, and alert on deviations that matter. A camera that suddenly speaks SMB or a sensor that begins issuing large HTTPS posts to an unknown host should be conspicuous, not subtle. Normalize metrics so spikes are defined relative to normal cycles. Then stitch device identity into flow records so investigations pivot from an address to this serial number owned by this team on this port. Baselines are not busy work. They are how you separate a firmware update from a foothold. Identity without posture is only half the picture. Before a device touches production data or control paths, verify what it is running and whether the state meets your minimum bar. Current firmware, required protections enabled, configuration hash matching the golden set, and no sensitive debug modes switched on. Enforce this with network access controls that check attributes at admission and on a schedule, because drift is inevitable. Devices that fail land in remediation enclaves with only the reach they need to update or request help. Over time, posture attestation reduces the number of unknown unknowns, the dangerous category where a device is online, functional, and quietly vulnerable. Management planes and vendor backends deserve scrutiny equal to the devices themselves. Monitor administrative portals and remote access paths for unusual sign-ins, new integrations, or permission changes that widen blast radius without review. Watch cloud connectors for anomaly spikes in data volumes, destinations, or rate patterns that suggest exfiltration, command abuse, or opportunistic mining. Require multi-factor authentication and short-lived tokens for operators, and log every consequential action with actor, time, target, and outcome. The goal is simple. If someone steers an IoT fleet from a console or a vendor bridge, you can say who did what and stop it quickly if it is not you. Actuation and sensing must never be a fire-and-forget trust exercise. Apply rate limits so commands cannot be spammed at equipment. Validate command schemas strictly so malformed inputs die at the edge. And add replay protections with nonces and short validity windows. For safety-adjacent operations, introduce two-person integrity or out-of-band confirmation for sensitive actions. And ensure the device reports what it actually did, not only what it was told to do. Telemetry should include success, failure, and measured effects so a valve that never moved cannot claim it did. These checks transform control from hope into a closed loop with evidence. Incidents happen, so write playbooks that assume a bad day and make safe choices the default. Isolation must be fast and surgical. Quarantine a single device or class without pulling power on an entire wing. Define fail-safe modes where devices degrade to the least risky state if they lose trust in commands or updates. Plan for degraded operations that keep core services running while you clean a segment. And script recovery so devices rejoin with fresh identities and inspected configurations. Practice these steps quarterly so the first time you push the button is not during a headline-worthy outage. The vendor's calendar will not match yours, so you need discipline around external change. Track advisories that touch your models. Require software bills of materials, SBOMs, so you know whether a new library issue is your issue, and treat end-of-life notices as risk, not trivia. Schedule patch windows that account for device duty cycles and maintenance constraints, and define mitigations when patches lag, segmentation tightens, egress narrows, and monitoring thresholds lower. Keep a short ledger that pairs each advisory to a decision, an owner, and an observable outcome. That ledger is how you demonstrate diligence when someone asks what you did and why. A brief scenario makes the approach tangible. A lobby camera begins beaconing to an unfamiliar host with larger than normal HTTPS posts at odd hours. Baselines flag the destination. Posture checks show the firmware is current, but the configuration hash diverged. And flow logs tie the traffic to a specific switch port and serial. The response playbook quarantines the single camera's SSID or wired port into a remediation segment, preserves packet captures and configuration for analysis, and triggers a replacement from spares. The viewing service continues uninterrupted because other cameras remain in their segments and the video system is designed to tolerate a missing node. After analysis, you push a signed configuration, rotate credentials, validate clean behavior, and reintroduce the device with receipts that explain the fix. We close by directing two concrete moves that reduce risk and create momentum. First, expand or build your IoT register from actual discovery, not old purchase orders, and ensure every entry has a type, purpose, owner, firmware lineage, and network locus you can verify on demand. Second, implement one segmentation change that meaningfully reduces blast radius for a high-risk class, perhaps constraining camera egress to resolvers and the video backend only, or removing east-west for badge readers, capturing before and after flows, error rates, and user impact. When these two artifacts exist, a living register and a measured reduction, you will have transformed IoT from a collection of black boxes into a system you can recognize, control, and defend. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.